Okay, cool. So today we'll explore the idea of undoing a function. This is kind of the big part of this unit. It's called inverse relation. Now, when we think of inverse, what does that mean when you hear the word inverse? What do you guys think of?
Opposite.
Opposite, pretty much, right? Like, what's the opposite of addition? What's the opposite of multiplication?
Division.
So those are inverses of each other. Addition is the inverse of subtraction. Multiplication is the inverse of division, right? And vice versa. We're going to focus on the inverse of exponential functions, which we did talk about in the fall. And we'll have a name for that, but we'll get there when the time's right. But for now, we're just going to focus on inverse relations when you switch operations, basically. So we'll look at in a tabular format, algebraically, and graphically. So in inverse relation, so just some vocab you need to know. Inverse relation, inverse function. Actually, there should be an F here and X here. So it should look like this. Lines of symmetry, horizontal line test, vertical line test. So these are all terms that we're going to be using. I'll explain what these first two are later, inverse relation, inverse function. But vertical line test, you guys should be familiar with that. Do you guys know what vertical line test is? What is it, Ben? You're nodding. What is it?
I said it's like actually a function.
Right. So the way that's going to look is that if a vertical line, actually, let me rephrase that. I don't like the way I'm writing right now. Let me put it as a text box. Here we go. So a relation passes this test if a vertical line crosses its graph no more than once. And the key phrase is vertical line. So a good example would be something like this here. So if I drew a bunch of vertical lines, right? Oh, should switch colors, sorry. Here we go. If I drew a bunch of vertical lines, how many times are the vertical lines touching the graph? Each one's touching once, exactly. Never touches more than once. So that passes. So that's a function then, right? That's what we use. Horizontal line test is the same thing, but instead of vertical lines, you're using horizontal lines. Same thing, right? So now in this case, let me write that again as a text box. A relation passes this test if a horizontal line crosses its graph no more than once. So the only difference is doing horizontal lines. So what if I drew, say, something looks like this? And say I drew a bunch of horizontal lines. Does this pass in the horizontal line test? Yep, this passes as well. However, would it pass this one here? The first one up, it would fail that one. Lines of symmetry, basically a line that cuts a graph in half. So both sides are mirror images of each other. You guys have seen that before, right? Like if I have a parabola, if I drew a dashed line like this, you see how that dashed line cuts that graph in half, right? And if I were to fold the graph along the dashed line, the left and right side are mirror images of each other, right? The left and right side are mirror images. So that's what line symmetry means. A relation, just so you know, is basically an equation with x and y. That's what a relation is, just an equation with x and y. A function, however, must pass the vertical line test. In order for a relation to be a function, it has to pass vertical. So that's like a special designation. All equations are relations, just so you know, because you're relating two variables, right? Give you a little more context. Let's say I had an equation like this here. And let's say, and give me some context here.
Excuse me.
Bless you. $1 fee plus. You don't have to write this down what I'm writing right now up top. But let's say you hire like a plumber to come to your house, right? They charge $100 for showing up, and then $40 per hour for the time you spend working on whatever they're doing in your house, right? So, give me some context. X, Y is a relationship, right? X would probably be the time to spend. Y be the money that you spend with on the plumber, right? That's a relation, right? Because you're relating two variables. That's why we call all equations relationships. I'm going to start using that word more and more frequently so you guys can kind of absorb that, right? So a relation is just simply an equation that involves two variables. And give you some context, like if X is time and Y is money, that's relationship. Now, is it a function? Well, it has to pass the vertical line test to be a function. And so we'll start investigating that down the road. But those are words we're going to be using a lot, relation and function, throughout the semester. Okay, let's move on to the next page. Let's actually do some problems. Okay, and I think after 5.2, we'll have you guys do 5.3 and 5.4 in your table groups. And then we'll do an activity after that, and then a few more problems, and you guys can do homework. Okay, so let's do 5.2 together. Just so, you know, it's been, what, 3 weeks since you've done some math. So our final is December 15th, right? So it's been almost a month, actually, if you think about it. So picture of Anita's function machine is shown, but we did this in the first semester, probably the first day, I think. She put a 3 into the machine and a 7 came out. Okay. Then she put a 4 and a 9 came out. Then she put a -3 and a -5 came out. Okay. So first we're going to do, I don't know what equation this is. So basically, there's a relationship happening here. Sorry for all the writing. So there's a relationship between X and Y. I just don't know what it is right now. So this is X, right? This is Y. X is what comes in, Y is what comes out. So let's make a table. Somebody's making a table just to kind of get a lay of the land, like, hey, what's going on here? What's the relationship? So let's make a table. Apparently, when you plug the 3 and you got a 7, right? And then you're told if you plug in a 4, you got a 9. If you plug in a 3, you got a -5. It's not terribly obvious what the relationship is. At least it's not clear to me. I don't know. If it's clear to one of you guys, let me know. Do you see it? Well, you know, do you guys agree? 2x plus 1? I think Plum is right. I think that's good. Okay. Yeah. It looks linear. Okay. So, but we make a table first, right? And then Anita's function machine suddenly starts working backwards. It is pulling outputs back into the machine, reverse the machine's process, return the original input. If a 7 is pulled back in the machine, what do you think will come out? So obviously, well, first off, what's the relationship? We'll go with what Plum said, because that's totally correct. Y equals 2x plus 1. That's relationship, right? Y equals 2x plus 1. Great. It makes sense because if you were to double this and add 1, I would get the output every time, right? So that makes sense. Okay. You could, if you wanted to, find the slope between these first 2 points, which is 2. And so happens the slope is also 2. But then you'd have to find the slope of the line intercepts, which I know you guys can do. You guys have done that before. I'm not worried about that. But there we go. But what if it work backwards machine? If the machine worked backwards, right? Then what's going to happen? If the 7's pulled back to the machine, what do you think will come out of the top? A 3, right? Just a reverse, right? So she sets up her new backwards function and enters the other outputs. So in this case, I'm going to swap X and Y. from part A. So I'm just going to swap it. So if you plug a 7 in underneath and it works backwards, what comes out? A 3, a 9, then a 4, and -5, then a -3. Now this part's not going to be terribly obvious. Do you guys know what the equation would be for this new table after you switch x and y? What do you think the slope is going to be? The new slope. It'll be 1/2. Yeah, the new slope will definitely be 1/2 if you were to compute it, which kind of makes sense because what's the slope right now? 2, right? What's the offset multiplied by 2? 9 by 2. So it kind of makes sense what we're seeing right now. That the slope would be, but we're going to talk about that in just a bit. But again, she sets up her new backwards function machine. So now the outputs become the inputs and the inputs become the outputs. So everything switches. We swap x and y from part A. And this actually is called the inverse. Because that's what you just did. You reverse things, right? Why we're talking about this, though, it does seem kind of vague. Like, okay, so what's the big deal? Whoop-de-doo. It is a big deal when we get to the new stuff in about a week or so from now. We start talking about something called a logarithm, which is the inverse of exponential functions. We have to understand inverses before we talk about this new topic called logarithms later in the unit, because it is a pretty tricky topic, but you need to have this knowledge before you do that topic. So I'm trying to hopefully set you guys up for success. So you're asked to record the inputs and outputs of the backward function. I just did that. So actually, I just did part D, guys. So you could cross it off. I did in part C. So explain in other words what the machine is doing. Okay, so let me let's do this here. Let me grab that guy, and let's erase the other ones. Here we go. Okay, so explain in other words what her backwards machine function is doing. So now what it's doing is that it's so before originally it was doing this, right? Y equals 2x plus 1. So it multiplied the input by 2, then added 1. Okay, that was the original. For the inverse, right? This is the inverse, right? I'll tell you right now what the equation is. I think I've got it right. Yeah, x minus 1 over 2. Yes, good job, Jack. Yeah, y equals x minus 1 over 2. Yeah, because if I do it every time, I do get a new answer. So what's happening here? Okay, what's the opposite of addition, guys? And what's the opposite of multiplication? And what did we do first here? We multiplied and we added, right? So we should also reverse the order as well. So we should subtract and then divide. Yeah, so now what's happening is subtract 1, then divide by 2. So originally, again, we multiply by 2 and add 1. That makes sense. When you do the inverse, you don't just do the inverse operations, you switch the order as well. So the equations we have now, right? Y equals 2x plus 1. That's the original. The inverse was this. Y equals x minus 1 over 2. And just to let you know what's happening, for the inverse, don't just perform the inverse operations from the original relation, but also reverse the order of those operations. That's precisely what we did. We also reverse the order, not just do the inverse operate, but we reverse the order. Okay. So that's kind of a big deal. Graphically speaking, it's not that hard. Actually, I'm going to go to Desmos right now, and so you can see what's happening. It's actually kind of cool. And this is kind of a big deal because we do have to see what's happening graphically as well. So let's go here. Y equals 2x plus 1. Y equals 2x plus 1. Duh, that's just the line, right? Y equals parentheses x minus 1 over 2. Okay, great. Let me clear my screen. And let me graph this as well. This is not going to be obvious, but I'm going to graph that. The green line. How do you think the green line is related to the red and blue lines? They do, well, they intersect there, obviously, but how's the green line related to the red and blue, though? What do you think the green line is doing? Is it going right in between the two? It will. This will always be true. Whenever you have the inverse, y equals x is the axis of symmetry. This is a very, very important thing. You may want to jot it down somewhere. Y equals x, the equation y equals x will always be the line of symmetry between the original equation and its inverse. That will always be true, 100% of the time, 100% of the time. If you've done it right. If you found the inverse correctly, that's what always happens. It's y equals x, same thing. Yeah, it's the same thing, exactly. Okay. Cool. Okay, so now let's move on to the next page. Any questions so far? Pretty straightforward, hopefully. Okay. So what I'm gonna have you guys, and actually one other thing I just want to talk about really quickly as well. I should probably just mention this. Let's go back. Let me write the equation one more time. Y equals 2x plus 1, and y equals x minus 1 over 2. What you could do, what you guys could do, is switch x and y, then isolate y. Remember, I had you guys do that thing called literal equations where there's like a bunch of variables and you get one of the variables by themselves? That didn't go so well in the final. And the reason why I spent time on that is because we have to do that a lot in this unit. We do have to actually solve for variables in terms of other variables. It won't be as hard as what was on the final. What was on the final is a little tricky. But what if I switch x and y here? Then I get this, right? X equals 2y plus 1. You guys agree? You switch x and y. Now, what did you get y by itself? What's the next step? Minus 1, and then what? And what do you get? You get the inverse. Yep, you get that as well. So we saw numerically by just swapping the two and then just trying to figure out what the equation would be. We saw algebraic, now we see, and graphic I just showed you on Desmos. Now it's showing all three: numerical, graphical, and algebraic. Algebraically is easy. Just switch x and y and solve for y. Table, that's easy. Just solve the columns. Graphically speaking, it's just more just once you have the equation, just graph it. But you can maybe try to get the equations from the graph and then make sense of it, or get the points and then see that the coordinates are swapped. That works too. Okay, so 5-3. So there's a few things you have to do here. And 5-4, there's a few things you have to do as well. So I'm gonna have you guys work on this page. I'm gonna walk around and help you guys out. I'll actually work out and pause my screen, and then we'll talk about it. And by the way, you're being asked to use this symbol with a -1 symbol. Just so you know, the -1 symbol means inverse, not 1 over h. Just so you know, that's a terrible color. Go back to red. Sorry about that. So it's supposed to be an X inside. I don't know. I'm not sure why that's not showing up. But this here is the notation for inverse. It's not 1 over h. Just so you know. It's a notation thing. That's all it is. So anyway, why don't you guys go and try 5-3 and 5-4? I'm gonna write the answers down really quickly and freeze my screen, and I'll come around and just see how you guys are doing. Remember, doing the opposite, guys. Hold on a sec, I'm coming by. Okay.
So actually, we're gonna part C. So here's the thing, so you want the fourth one on the top, right?
Oh,
So
the first equation is inverse.
So the first, so the equation to get 5x plus, that's actually the original. So what happens if you put 4 in? What do you get?
22.
22. So that means I gotta put 22 into the inverse to get 4.
So A is inverse.
Not, was that, sorry?
Is the first problem we're working with the inverse equation?
No, you're working with the originals. That's confusing. You're working with the originals.
So we try to find 5x plus 2 equals 4.
No, because 4 is plugged in this. 4 is gonna be plugged in for us.
So the answer is just 22.
Right, because you want 4 to be the alpha. Okay, let me back up, guys.
Yeah.
Let's back this a little confusing. So if you want 4 to be on top, you want 4 to be the input.
Oh, okay.
So let me if 4 is the output for the inverse. This will be up, guys. I probably explain. Then
I just wrote the equation, but the answer is
4
yeah, there's not an answer. I think the answer
is the input.
it's like y equals x minus 2.
That's what key guys. If you're told 4 has to be the output going backwards. If you're going backwards, that's the input. Right? So actually, Alex, you're all right. Part A is talk about the original. This is the original. That's the original, right?
Yeah.
Part A is asking to do the inverse. So you want 4 to be on top. So you want 4 to the output of the inverse. If 4 is the output of the inverse, the 4 has to be the input to the original. It has to be all opposite. So in this case, you just do this. You just plug 4. That's really what it's asking. I know it's confusing. Why don't you say, hey, just plug 4 into the original function? I know you guys can do it. But if you're told 4 has to be the output for the inverse, guess what? It's the input for the original. So 4 is the output for the inverse, 4 is the input for the original. So now the next one is Julia wants to build a new machine that will undo h of x. Will undo what h of x does to the input. So if you think about it right now, what is the original doing? multiply by 5.
Then adding to.
So do the opposite. Do the opposite of 17.
So B and C are basically the exact same thing.
Yes, exactly. Yes, right, go ahead.
For B,
Yeah, you got,
that's it?
Yep, that's it.
Simplify?
Yep.
Like,
Yeah, you don't have to do a mixed number or decimal, that's fine. And proper fractions are okay.
Okay.
Yep, you got it. Yep. Yeah, once you guys finish 5-3, try 5-4. You got 5-4? Hold on, yes.
Yeah, given
Let's see, add 5 by 2 cube multiply 6. So doing the opposite now, you divide by 6, you cube rooting, and multiply 2 and then subtract 5. Yeah, you got it. Yep. Well, actually, you already took care of the parts you already did in part 1. You already took care of it. And then you plug in 15, sorry, 17 for that. Right. Yeah. Hold on, I just want to make sure. Oh, wait 1 sec. Oh, Charlotte, actually, your answer for part D is incorrect. I made, no, you got part D, right? No, mind, you're good. Sorry, you're good. You're good. You got part D fine. That's yeah. I know, it's.
Wait, is it in the output, is that being put in, so it's actually put in, right?
Okay, but if you.
No, that's yeah, I guess we do.
Okay, yeah. Yeah, it's also. How would you do the inverse?
You rate the part two.
Which would you have to.
First. Then if you bring it to double by 2,
Six X, 3.
yeah.
Right.
Yeah, I guess. This is just an indication that you're gonna get percent. All right. So,
The inverse is the.
so for example, so you.
X divided the third.
The opposite. Even now. You can write it either way. You write the Y, but when you do this, this tells like whoever's like, oh, well, I don't know. I'm not asking a question like that. This question that I have, we're just scratching the surface right now. Don't worry about that. But what you need to know is like when you see this symbol, you have to like tell you like find this. You have to recognize what it's.
Oh, you're right.
Whether you do this or not, I don't really like it. That's not quite a question. Because we still haven't got the people of the stuff yet.
I don't know.
So it's more just understanding. That's all.
Which is inverse. Oh,
Oh, wait, no, mine's fine. Oh, mine's fine.
Yeah.
I don't know, actually. Good question. I'll find out. I should know.
So.
Yeah. Okay.
So
Okay.
six.
So you're doing good so far. Okay.
For D, do you plug it in?
Okay.
You plug into your equation on part C. Yeah, the inverse, right? Because that notation, you see that H -1, that means you gotta plug into the inverse. And because now we know what the inverse is, you know, that's minus 2. That's good. When you see H -115, you plug 15 into the inverse.
Oh, because the input is.
Exactly, correct. We'll make the check on Charlotte here. Yeah, go ahead.
I don't think I.
Okay, so you just got to do the opposite now. So, so you first got to divide by 6, which you did.
Yeah.
You cube. You got a cube root actually.
I hear right here.
Oh, okay, but it's got to be cube root because cube root is the opposite of cubing. So you got to do a radical.
Okay.
So here's the original. The original is this: x plus 5 over 2 raised to the third power times 6. That's the original.
Mhm.
Y equals that, right? The inverse would be just do the exact opposite and go in the reverse order. Divide by 6, cube roots, divide the whole thing by 2. Sorry, multiply the whole thing by 2. That's opposite division, right? And then subtract 5.
That's what you know.
You just do the opposite.
Alright.
Okay, guys, listen, let me show you what's happening here. And actually, let's look at the time as well. Just want to be mindful of time. I know you guys still have another thing, but kind of a tough day for you guys. So, we get at 1:50. Okay, so I promise I won't. I'll probably end in about 10 to 12 minutes. The less you guys have some time to work on homework. Okay, let me get back to. Should pause the video too. Okay. Anyways, let me go and clear. No, not clear my screen. Unfreeze. There we go. Unfreeze. Perfect. Let me go back to the notes. Okay, here we go.
Where's the board? So anyway, what's happening here is you're being asked to find the inverse. But remember, the force output for the inverse, because when we say the crank is turned backwards, that means inverse, right? If it's going backwards and forwards, I'm doing the inverse. Well, if the force come out of the inverse, it means force got to come in to the original, right? Just the opposite. So I put 4 in the original 22. That means that if I put 22 in the reverse direction, the 4 comes out fine. Because guess what? What does this mean? Now it means I got to subtract 2 divided by 5, right? Subtract 2 divided by 5. This is the opposite of this. This is multiply 5 add 2. What's the opposite? Subtract 2 divided by 5. So that's why we have this equation here. X minus 2 over 5. So one thing you can do is write the original, swap x and y, and then just solve for y. That's the best way to do it, just saying that. Swap x and y, solve for y. So the notation looks like this. Now, Monty asked a good question, like, well, if I wrote this instead of h-1, would I lose points? No, because you found the inverse. I don't care whether you write y equals or h-1 equals. What I do care about is you know what that means. You know it means inverse of this. That's what I care about. And if you were like 15 into your inverse, you should get this. So that's 5-3. Any questions on that? Okay. That's 5-4. Let me just do it really quickly with you guys. So for part A, the original function is going to look like this. I'm going to add 5 to x. I'm going to divide by 2 because, just like Simon says, just do what you're told. Cube it. Great. Multiply 6. Boom. There you go. That's g of x. So guess what? Help Keiko write down steps of the inverse. Well, that's easy. Let me just type it up. For part B, easy peasy, right? You're going to divide by 6. And this should really drive the point home what we're doing here, right? We're just doing the reverse, but going in opposite direction as well. Divide by 6, cube root, multiply by 2, subtract 5. And just write it. There you go. So then I'm going to write like this to show that I'm doing the inverse. That's going to be divide. So x over 6, then cube rooted, then multiplied by 2, and then the whole thing has to be subtracted by 5. Does that make sense what I just did? Right? Just did reverse. Now let's verify. How would you verify it? For part C, here's how I'd verify it. Let's do like g of 1. What's g of 1 going to be if you work that out? If I plug 1 into the original. Yeah, actually, yeah, I think so. So that's 6 over 3 cubes 27. 27 times 6. What's 27 times 6? It should be 162, I think. I think it's 162. Yeah. Yeah, does that make sense? Yeah, because you divide by 2. 1 plus 5, 6 over 2, 33 cubes 27. Yeah, it should be 162. Now, what if I do this here? Plug in 162 into your inverse.
What's 162 divided by 6 now? It's 27, right? So 27 times 2. Wait, cube root of 27, my bad. Yeah, it'll be 3 times 2. 6 minus 5 is 1. You get back to 1. Yeah, sorry, it's kind of tucked away there. But yeah, that makes sense. That's how you verify. So plug in a random number into your original, see what the output is, and reverse it and see if that's true for the inverse. If it is, you did it correctly. So you're good? Oh, yeah, of course. Yeah, go ahead. Yeah, yeah. Totally. All right. So let's move on, guys. Let's not worry about this activity. We'll forego it. I think you guys get the idea now. So let's just do a couple more examples. I'm not going to do the one extra for experts. That's if you guys want to try that. Go ahead. But let's look at 516 really quickly here. And 517, you guys can start the homework. All the examples so far have inverses that are functions, but not all equation inverses are functions. So here's the thing. For the inverse, let me type this up again. But inverse relation to be a function, the original relation must pass the horizontal line test. It's hard to read. Sorry, let me resize that. There we go. Yeah, for the inverse relation for inverse relation to be a function, the original relation must pass horizontal line. So these are all the originals, right? These are all the originals. Let's think about it. Does this pass horizontal line test? Yes. Does this pass horizontal line test? No. Does this pass? No. So this would be yes, no, and no. So look at each and decide which inverse will be a function. Again, this is yes, no, and no, because it fails for the second and third, but passes for the first one. That's where the original would be a function, which all of them do. So for the inverse, if you were to actually find the inverse, which actually I could find for part A and part B, the first and second, I could actually switch X and Y to solve for Y. I think it's impossible to isolate Y here if you switch X and Y because you have Y cubed and Y. You do that. But in order for the inverse relation to be a function, horizontal line test must pass for the original. So that's why we have the horizontal line test. That's why it's there. So for a function that for an equation to be a function itself and its inverse to be a function, then you have to pass both vertical and horizontal. All these pass vertical. All these are functions. But the inverse is only a function for the first one, not the second and third. Now, next up, you're asked to draw the inverse. This is a good, I like this one a lot. This is a great activity. After I finish this one, we can start homework. Okay, so the graph of two functions shown below, draw the inverse on the same graph using a different color pen or pencil. Fine. Okay. Here's what I would do. Now, I'm going to do green. The original will be in green. Actually, let me take it, because right now everything's in red for the original, so I'll take it back. The original will be in red. The inverse will be green. Okay, so let's make a table, actually. Let's make a table for each of these here. I'm going to keep it kind of simple. So what are my coordinates here? -2 and 4, -1 and 1, 0 and 0, 1 and 1, 2 and 4. Okay. Now, we swap. 4, -2, 1, -1, 0, 0, 1, 1, 4, 2. So this is the inverse now. And remember, red is original. So guess what? How am I going to draw the inverse? Just plot the points after you reverse the table, right? So 4, -2 is right here. 1, -1 is right here. 0, 0 is still the same place. 1, 1 right there. And 4, 2 right here. What kind of graph am I making now? It's a sideways. Yeah, it is a squared also. It's a sideways parabola. Totally. Yep. And guess what? If I drew this blue line here, which is y equals x, see how y equals x goes right to the middle? Goes right to the middle.
As it should. You've done it correctly.
So all I did was I located points. So let me kind of give you a, it's saying cookbook recipe, but identify coordinates on original, swap them, swap x and y to get points for inverse, then plot inverse. That's all you guys are doing. Identify coordinates on the original, swap x and y to get points for inverse, and plot the inverse. That's all you're doing. So let's look at the line here. Let's go back to red. So where are some points on the original? 0, -1. No, yeah, 0, -1. It looks like it's probably 1/2, comma 0. I don't know why I chose a fraction, my bad. And 1, 1. Is that right? Yeah? Okay. So for the inverse, let's go to green now again. Back to green. You swap. -1, 0, 0 half, 1, 1. -1, 0. Okay, not terribly straight. I could do better. A little better. And let's do this blue line here. See how the blue line goes right through the middle? So any line symmetry, yeah, y equals x. I already just talked about that. For part B, are the inverses functions? No. For the parabola. But yes for the line. No for the parabola, but yes for the line. And how do you know horizontal line test? On the original. Or vertical line test for the inverse. If you want to do that, you can do that too. So, okay. I think that's line symmetry identifying 5 that can be used to help graph the inverse. I already talked about how to do that. Just swap x and y for 518. I already talked about. Actually, it's not even there. So, anyway, cool. Okay, so we're good. Our homework is this. The second page is if you want extra practice. Now, some of you guys need to start thinking about what math class may want to do next year. Majority of you applied to at-level pre-calculus. So you might want to do pre-calc AB honors. The requirement I think is an A minus, and the second semester overrides the first semester. So if you do want to do pre-calc AB honors because you want to do AP Calculus AB 2 years from now, sure, that's great. But if you want to put yourself in a good position, if that's what you're interested in doing, the extra practice problems would be a good thing to do. If you don't care for that, then don't do it. So, but the homework really is just going to be the first page here. I'm going to hand it out in just a sec. Some of it's old stuff. The answers I don't have yet. Let me create that while you guys are working, and I'll post to Schoology so you guys have it. And also I'll post the assignment in Schoology so you know where to upload. Because you're still going to upload homework, right? That's still, so that's how we do homework. You just do it and upload to school. So anyway, let me pass it the homework, and we're all done for lesson today. Let me stop the recording.